Okay, we're going to review our logarithm essential skill. This video is really made for you guys to pause it right now, write down the problems you see, and then answer them. This is not really made for me to teach you how to do it. This is just a quick review. So go ahead and pause your video and try to compute those 4 problems that you see on your screen. Just a hint, when it says compute, you should be getting a single numerical value as your answer. Pause your video. Okay, so I started number 1. When it's compute, I like to set it equal to x because that's what it's asking me to find. What is this logarithm equal? Rewrite it as an exponent, so that's 2 to the x equals 1 over 8. Then remember to get fractions, the exponent must be negative, and 2 cubed makes 8. That's why the answer is -3. I'm going to go through and do the rest. Pause the video if you don't want to see my answers yet, and then unpause it and see if you got the same thing as me. Okay, so there are my answers. 25 to the x equals 5. We all know that we want to square root 25 to get 5. If you want to square root something as an exponent, that's when you use fractions. That's why the answer is 1/2. 3 to the 4th makes 81. The answer is 4. On number 4, laws of logs say that you multiply. So 25 times 4 is 100. The imaginary base is 10. So 10 to the x equals 100. X must be 2. Here's another page of review, condensing or expressing as a single logarithm. Write these down. When you're done, you should have, for example, I'm going to erase this in a minute, log, I'm in shapes, log 3 of one big thing, and chances are there's a fraction in it, but notice there is only a single logarithm written. So pause your video, copy these problems down and try them on your own, and then unpause it to see if you get the same thing as me. Okay, so here's my first one, so you can check and see before you get too far. First thing I did was the exponent. Exponents in front of logarithms become, coefficients in front of logarithms become exponent. 4 squared is where I got 16. Then I wrote the rest of it down, so do all your coefficients first. Then anything that's positive stays on top, so this logarithm's positive, that's why the 16 is on top. Anything that has a minus sign, subtraction in logs means divide. So those go on the bottom, but they don't go on the bottom as 52 or 52. You multiply them together, so there's 10 on the bottom. And then we do expect you to reduce it. 16 over 10 reduces to be 8 over 5. So see if you can do number 2 on your own, and then unpause it to see my answer. Okay, exponents first. A single logarithm. Positive ones stay on the top. 5 is positive, the x squared is positive, and the y cubed is positive. They all get multiplied together if I could multiply them together, but numbers and variables, you just write them next to each other. And then z to the 4th ends up on the bottom because it was subtraction. Here is the next slide of problems for you to write down. Notice that now we are on to just rewriting from exponent to logarithm form. Logarithm. So if it's an exponent right now, change it to a logarithm problem. If it's a logarithm right now, change it to an exponent problem. Pause your video. Okay, here are my answers. One thing to keep in mind, so we're just doing that rewrite from log to exponents. It's easier for me to show you over here on this one. 3 is the base, raised to the number on the complete other side of the equation, 3, equals 27. So the numbers that were together in the original are never together again in the rewrite. So same idea over here. The base is 5. That's why it became my base of 5. The 5 and the 3 can't be together anymore, so that other number goes next to log base 5, and then it equals 3. So check out these answers, and then we'll move on to the next slide. Okay, here's your next slide. We are solving for x in all of these. See what you can do on your own. Pause your video, and then I'll go through them one at a time. I'm going to show my full solution in number 1, so you should do it ahead of time, and then I'll talk about what I did. Pause your video. Okay, so on number 1, the logarithm was all by itself to begin with on the left-hand side, so I was able to go straight to rewriting it as an exponent problem. 2 to the 4th equals x, and then since 2 to the 4th is 16, x equals 16. Number 2 is similar. See if you could do number 2 all by yourself. Pause your video. Number 2, the logarithm's all by itself, and it's equal to a whole number, so I change it to an exponent problem. X cubed equals 125. These are powers that you should have memorized. 5 cubed equals 125, so my answer is 5. You can try number 3, or you can listen to me talk about it. Get the logarithm alone first. I was purposely pointing out the fact that in 1 and 2, the logarithm already was alone, And number 3, you need to get it alone. Now you can solve that just like the other ones. 2 squared equals x. X must equal 4. Try number 4. Logarithm all by itself. 2 cubed equals x minus 4. 2 cubed is 8. Now we just have one more step to get the x alone. X equals 12. Okay, here is our next page. See if you can solve these. Plus between two logarithms means you multiply it together. Notice I did not make the logarithm just disappear. It is law of logs that tells me to multiply them together, so you better still have a logarithm there when you're done. Now it is 1 logarithm equals 1 number. Rewrite it. 3 squared is 9. To get x alone, you divide. We do expect you to reduce fractions if necessary. 9 over 5 does not reduce, though. The decimal equivalent is also acceptable. Number 2, get the logarithm alone. When there's only one logarithm in a problem, you need to get it alone. Rewrite as an exponent. Do the exponent. Get x alone. If I'm going too fast for you, that's because you were supposed to pause the video and try it on your own before you press play. Okay, here is our next set. Pause the video and copy these down. Okay, I've started number 1. Logarithm was all by itself, so rewrite as an exponent. When you do, you get 4 to the negative 2. Remember, 4 to the negative 2 is 1 over, and then 4 squared is 16. To get x alone, you would add 6. You could write this as a mixed number, which is my preference in this case, or as a decimal, or as an improper fraction. Whatever the equivalent to 6 and 1, it shouldn't be 12, sorry. Don't change the problem. 6 and 1/16 is. Same idea on number 2. See if you can finish all of these. I'm going to, next time you press play, I'm going to have all my solutions written out. Okay, there you go. Rewrite number 2, 1/9 minus 1. 1/9 minus 1 gives me negative 8/9. Rewrite number 3, x cubed equals 5. To get x alone, I take the cube root of both sides. Since I can't actually cube root 5 in my head, I just leave it as the cube root of 5. Similar, number 4, the answer is 5th root of 8. Next slide. Notice there's more logarithms in these ones. I keep telling you if you can get the logarithm alone, we can rewrite it as an exponent problem, which is important for number 2, if you'd like to do that one first. But we need to look at number 1 together. I have log base 5 of something equals log base 5 of something. Since they're both log base 5s, the somethings must be equal. This is the one time you're allowed to basically cross out your logarithms, because whatever you're taking the log on the left side of must equal whatever you're taking the log on the right side of. Solve for x. X must equal 3. Number 2, 2 logarithms on the left-hand side. Condense those together. Pause your video and see if you can condense those together correctly. Plus means multiply, but you've got an expression times 2. You need to make sure you distribute that 2. Also, make sure that your logarithm did not randomly disappear. Laws of logs let me multiply them together. 2x plus 6. Now, 7 to the 6th, I made these problems up, so we'll just go with it, equals 2x plus 6. I don't expect you to do 7 to the 6th without a calculator, and I don't have one in front of me, so I'm just going to leave it like that. 7 to the 6th minus 6 equals 2x. Divide by 2. This is something you could expect to see in higher level classes. Just leaving your answer in exact form, just like this. solving for x. Similar to the previous slide, see if you can do these on the own, and then I'll go through them one by one. Okay, so two logarithms together with plus in the middle means multiply. So log 3, it's still there, of 6x equals 2. One logarithm equals one number, rewrite it as an exponent. 3 squared is 9 equals 6x. Divide and reduce your fractions. Make sure you reduce it. See if you can do number 2. Okay, so exponents first, coefficients become exponents. Log 7 of 4. Minus means divide, so that's really log 7 of 4 over x. Log on both sides, the insides must match. 4 over x must equal 5. Put it over 1 and cross multiply if that helps you. And then x equals 4/5. Last slide for today. See if you remember how to solve these problems. Hint, if you don't remember, you need to get 7 to the x alone. You've got to figure out this part. But before we're ready to do anything with logs, you need to get that base with that exponent alone. Same thing down here while we're at it. Get 5 to the x plus 6 alone. Pause your video. Okay, so I got as far as I told you guys to go. I'm happy if you kept going. You cannot multiply something with an exponent times something that does not have an exponent. So first step was -1, then divide by 2, and then I got the 7 to the x alone like I wanted you to do. Then you can take the log of both sides. I just like to squeeze it in front. I change colors so you can see what happened. By taking the log of both sides, log base 10, but technically you could do any base you want, but base 10 is easiest, I'm allowed to move that exponent back in front. We've been doing it the other way a lot. Same rules apply the other direction. This is just a multiply problem, so to get x alone, I just divide both sides by log 7. X is going to equal log 4 over log 7. You should also know that when I was at this point, 7 to the x equals 4, I could have rewritten that as a logarithm like we were doing earlier, right? The base is 7, so it's log base 7 of, the 7 and the x can't be together anymore, so it's of 4 equals x. Those are two equivalent answers. Either answer is 100% acceptable. They are both correct. See if you can do number 2.